What hubole, my dear ones. It's been a while since you've seen me around here, right? But do not think that I was going to disappear from the map. Here I am, and I am going to continue talking about cool things about radio communications. It turns out that I fell into my hands some radio bases from Hytera, the HM685. And what caught my attention is that on the back, they have a very flirty network port, with which a rather curious function is unlocked, the IP-Transit. According to the manufacturer, this wonder lets you connect multiple radio networks on the fly into one using the IPY port. Yes, one. I would think, gee, this looks good like Shio's radios. Yes, those strange inventions that I once talked about on my channel when we were talking about Motorola mobile radios. If you haven't seen it, turn around because the talk is very good now. Be careful because it's not exactly the same. IP-Transit has its differences, its advantages, and also its limitations. But for starters, what it lets us do is join different radio networks together as if it were a technological roast. Everyone brings their own, but in the end, everyone lives at the same table.
Well, Raza, now yes, no. It's all honey on flakes as the manufacturer paints it, yes. IP-Transit lets you put radio networks together, even if they are very far from each other, and even combines different frequency ranges. For example, a network in Vefi, another in Ujefipum can be mixed as if they were mezcal with lemon. But here comes the detail, the famous one. But for the magic to work, the radios have to use the same keys and the same call groups, that is. If you have two different teams and you want them to talk to each other nicely, then at one plane you are going to have to reprogram it. None of her was plugged in, and let's go. And one other thing, unlike the Eslios radio we talked about the other time, the IP-Transit is not compatible with repeaters. That is, you can connect mobile or portable radios. But if it occurs to you that you want to join two NEL repeaters, that won't work. Why? Well, I'm going to uncover those little by little, as if it were pigeon corn.
And here comes the mere net of the planet, my compass. IP-Transit does not pull when the transmission and reception frequencies are different. I mean, if you were dreaming of connecting everything with repeaters as if nothing had happened, well, sorry, but it doesn't work. Yes, the radio comes with its IPB nice interface, but forget about using it with IP Side Connect, just plug in and go. That is organized differently, so sadly you are not going to be able to save as much on irons as the manufacturer promises. Simply put, the thing works great for setting up networks with radios, cell phones or laptops, but if you add repeaters, the party becomes more complicated. And yes, there is a way to do homemade tricks, put some technological crutches in it to make it work, but that's not how they sell it to you. Plug it into the internet, make a couple of clicks, and let's go. Strong because the manufacturer is not naive at all. They're not gonna invent something so you can save wool. They want yours, so here's the thing.
The net IP-Transit. Yes, it's a cool bulb. If you have a good bunch of mobile radios, you can cover large areas of responsibility, almost as if you set up access points, mobiles, minibuses, antenna, satellite. I mean, if you put coconut in it and plan it well, you can build a pretty big radio network for teams that travel over great distances. But since we've been talking about obstacles, there are two other white hands pointing to the right. Third limitation. Channels that are working via IP-Transit cannot be entered in magnifying glass scan to the left. Forget about putting them on scan lists because they just don't walk there. White hand pointing to the fourth right, limiting the number of radios you can hang on the network with IP-Transit. And here comes the curious thing. The manufacturer doesn't even say a word. Cold sweats. I looked for official info manuals. I even dived into forums and nothing. So I don't know exactly how many stations you can have in this configuration. Maybe in the future they won't let go of the soup, but for now, person shrugging. There's no answer.
Hytera's band didn't fall short, huh? With IPI Site Connect, they had already demonstrated that they knew how to do the task of scaling networks well, and I believe that with IPI Transit they also applied a lot. So in that aspect there is not so much anger now. So as not to stay in pure theory, let's go to the practical examples of how this role is configured. The thing is, we have two radio networks, one in Kiev and one in Yalta. In each one there is an HM685 base working on different frequencies, but within each network, transmission and reception are the same. In addition, both networks also have portable radios connected to the system so that there is no shortage of chatter in the field. So, what's next? Well, let's get into the topic of code, blocks, and configurations. And here goes the first parish notice. For IP Transit to work, you need to have the corresponding license activated on your unlicensed radio. This doesn't start that simple. To check it, you have to go to the radio menu and verify that the license is active.
So, what's the first thing to do? Well, check the entrance ticket license. Without that, forget IP Transit. White hand pointing to the right. Step 1. You open the PPS on your computer, white hand pointing to the right. Step 2. You connect the HM785 radio to the laptop with its plug cable, white hand pointing to the right. Step 3. You read the settings and in the menu it will appear if you have the IP license, transit or not. If you see that you don't have it because you don't even have to go through the box bundle of bills with wings. The license costs more or less 500 to 700 hryvnia per radio, give it the equivalent of a few very expensive tacos, taco face crying with laughter if you have it activated. So, if we move on to the next step of configuring the network, you have to assign its own IP address to the white hand base station pointing to the right. For that you go to Access IP Settings. Inside the software is half hidden that menu like an Easter egg, but there it is. First we open the Kiev base, and there in IP set teams you indicate the IP that is going to touch that station, a symbol of danger. Here is an important detail. Your IPs have to be well thought out so that they do not collide with each other, because if they are repeated, forget it. A disorder worse than traffic on the peripheral, on a Monday morning, car and traffic light.
Look, the thing is like this, in the system there will always be a master radio, the mera, and all the others will connect to it as if they were its friends or clients. The teacher needs to have one static P of those fixed ones that change all the time. This is similar to what they call one IP SI connect addresses. Client radios can bring static or dynamic address, but if you use static the connection is made faster without so much turning. Network. All radios must be on the same network, but you can also use the open internet. The important thing is that the master radio has one public IP fixed, the famous white security. The signal travels well protected with encryption AES 2056 or Pro level encryption. Be careful, here the connection is only encrypted if your radios are configured to use AES 2056, if you do not activate that option. Well, the net signal travels in clear type extra. If you want more security, you can set up a VPN tunnel to make it even more armored. White hand pointing to the right. In short, one radio commands the teacher, the others hang on to her. You need one IP fixed, and if you activate encryption AES 256 or one VPN, your communication will be very secure.
Look, you can use the Armed Forces network. Yes, the net is slow, so it falls all the time, but well, it is in all the battalions. It is like the Mexican post office. It will not be the fastest, but it is there and everyone uses it. Now, if you want to assemble your own tunnels, VPNY also share them with other squads. Go ahead, no brawl, just water. Because you're responsible for making sure that network is always working. Now entering the technical part in the IP settings, you first define who is the master, the main station, and who are the slaves that connect to it. For example, in the master you set the fixed IP, and in the slaves you can use dynamic IP without problem. Then in network settings, You have to say where you are going to connect and what role you play if you are master or slave. All this is in the General Settings Network section. That's where the Site Connect EP show comes together. And if we talk about repeaters, well, in the configuration menu you choose your master station, go to General Settings, and from there you adjust everything necessary. In short, the military network is like the mail, slow but secure. If you set up your VPN, you are responsible for keeping it alive, and in the config you only have to define if you are master or slave and set the IPs correctly.
Well, since we enter the network part, if we lower it a little, we see several things as we already said. Here you put if you are a master, you configure the size of the buffer you define, the access key. I don't write down the master's IP because it is pulled directly from access. I do indicate the UDP port so that it is clear. Now in the slave the thing is very similar. You still put the buffer. The access key has to be the same as in the master's degree, otherwise it's not a joke. Connect in the master's field. IP, yes, you write down the static address of the master. And again, the ports have to match exactly with those of the masters if the communication is not broken. Those are really all the network settings you need to put in. The next step is the radio setup. If there is not so much science, programs, your channels, just like always. I'm not going to dwell on describing each button because it's the same thing you already know. When putting together any channel, just remembers. Do this from the channel settings section so that it is saved as it should be. In short, in master buffer key ports without IP because it already pulls it in slave the same. But here if the master IP goes, ports and keys are always the same. Then just program the channels as usual.
Look, when you're setting up the channels on your radio, there's a very important point. On key frequencies or whatever area you are programming, you have to make sure the IP transit check is checked. Why? Because if that little box isn't activated, your radio is basically not going to come online. IP. In other words, it remains isolated and no traffic passes through the internet. Now you may find that IP transit check appears deactivated in gray. Why is that happening? Here are the most common reasons. If it is marked LX only below, forget it. IP transit will not work if you have a scan list active, nor will it pull the IP transit. If the receive and transmit frequencies do not match, for example RX on one side, weight X on another, will not pass either. There are little details that seem small, but they are the ones that give the most headaches. So, the golden rule always marks the IP transit when you set up your channel and second detail. When you connect radios to different networks, make sure that they all use the same access key, otherwise they will not be recognized. In short, well Mexican, activate IP transit, otherwise your radio will not connect to the network. Be careful with LX only scan lists or different frequencies, because there it thunders and so that everything ties up. The keys have to match between networks. Here's something key, the cipher. If the encryption keys don't match between radios, the audio is just not going to decode well. That is, you will hear noise or nothing even if the signal is coming. The second thing you have to take care of is the group call IDs on your network. If they don't match, you won't hear what's happening in the group, even if the base radios are exchanging data between them. You're basically gonna stay out of the conversation. Then in the topic of portable radio setup, Hytera P7 Warnet 85. The thing is simple. They are configured almost the same as a mobile vehicle radio, but here you only work with the radio frequency part, not with network settings. That means same frequencies as the other radios, same encryption keys, same individual and group call IDs, same call keys. Simply put, all the radio parameters have to match the finger for the system to work. In the end, what you do is put together a well-structured code plug. For example, I can have 0 to 1 Kiev base. And from there we set up the other channels with the same logic summarized to the Mexican. If the encryption keys don't match, there's no audio. If the group IDs don't match, you hear nothing from the group. Laptops HP7885 are configured the same as mobiles, but only at the same RF key frequencies EIDs. Everything is stored in a neat code plug. Example, 01 kit base channel.
Example of configuration of radios, radio 1, 0, DO and high base of base station radio DO, 0, 3, CAPI portable working with the first base, radio 3, 0, 4 and high portable working with the second base. Also, a 4-page booklet with the instruction for the HM785 is included. The net says almost nothing about the IP transit. But hey, it serves as a basic guide. We also have the diagrams you see on the screen, important details of IP transit. If you use AES encryption, the key must match on all radios, docks, and laptops. Prioritization between laptops does not work, that is, there is no hierarchy of who speaks first, which does work wonderfully. Radio availability check. Remote monitoring, remote on-off of stations, data transmission, in short, everything else pulls very well, as long as the encryption keys match. Summarize Mexican style, the encryption keys must be the same on all radios. Forget priority between laptops, the good doesn't work. Monitoring, remote control and data transmission, if they go 100.
The same indicators are seen on the base and the same can be seen on portable radios as well. In the reverse case, everything works the same. 120, I increased the volume a little, 1 note and 223. That is, everything works the same way. Analogously, they can use base stations to make calls 1, 2, 3, 3. There is a small echo here, but all radios receive it. Well, now let's try. Turn off the remote portable radio. I go into the contact list, find this portable radio, select radio. EC available radio monitoring 11234. Look, the radio is listening in receive mode only. Well, we already have the base on sound activated. We tried 112223. The radio doesn't transmit anything yet, but we see that if there is information exchange, now we are going to do the test of turning it off remotely. Ready, the radio turned off, we turned it back on and perfect, it's up again. Let's try the remote base station now. First we check that it is available. Yeah, there it is. We turned it off and, indeed, it was out of service in the air. They no longer transmit anything to the laptop because the base is off. Now we bring her back to life. Fire up the base and good, the radio came back on. Of course, you have to wait a little because the network needs time to reconnect to the IQ system, but in a few seconds it should be working.
This usually takes up to 2 minutes depending on the configuration you have or the dynamics of the test. 1, 2, 3, 1, 2, 1, 2, 3. That's how it works now. Let's see what happens if the call EDs and encryption keys don't match on the radios. For example, on some radios we changed the ED call and in others we slightly modified the encryption key. Look at what I want to show you, an example of what a misconfigured codeplock looks like on an IP system, transit. Suppose we have a radio in Yalta. We get into the encryption part and move the encryption key to it. In the meantime, the portable radio keeps the original key. At Kiev Radio, we went into contacts and changed his caller ID. We adjust it here. Since we have that, we load the new code pluck into the radio and see how everything behaves.
Well, look, I already adjusted the radios. First base Kiev has one different call ID. The second base, Yalta, has a different encryption kit. I lowered the volume a little so as not to make noise, and now we are going to turn them on completely. And see how the laptops react. Let's try World 33. See that the base radios are still transmitting voice. 1122. Everything works on both sides. Now I turn off the sound on one laptop and turn on the other one that has the wrong key and do the test. And here's the fun part. Audio can be heard, but totally encrypted, incomprehensible. That is, the communication is not decoded because the keys do not match. Quick conclusion. When the IDs or encryption keys do not match, transmission continues. But the voice is illegible. This is super useful for testing security and seeing what happens to poorly configured radios.
Look, here's what's going on. The voice is transmitted from the first base to the second handset, but is encrypted from the first base. When it goes through the internet, it is still encrypted and reaches the second base without anyone being able to hear it clearly if we use AES 256. We can use the open internet without worrying about someone spying on us. And if anyone tries to intercept it, good luck deciphering it. Now let's try turning off one base and turning on the other. I'm trying to transmit on a 23. Nothing is heard because there is no password match. But we can see that the radio recognizes the caller ID it is being transmitted by. Even if that radio doesn't have that ID on their network, we're gonna run another test. Let's call someone from that radio 1, 2, 3, 4, and that's it. It works, but all encrypted. No one can hear the content if they don't have the right key.
Well, there's a curious detail. For some reason, the laptop starts receiving signal, even though it doesn't have the ED. Correct call. The second base, on the other hand, does not hear anything because here the difference is double encryption key EID call. Normally, if the caller ID doesn't match, nothing is heard. But hey, the Chinese invented this. Who knows why? Golden rule: when you connect radio networks, the caller ID and encryption key must match exactly. This is different from traditional Motorola radios where it no longer works. Mix IDC keys here transmits encrypted signals, so any mismatch and you won't hear anything. Thank you for your attention. I hope this material has been useful to you. Unfortunately, these licenses reached me very late, so I was only now able to make this video.
Clap closing video closing message. Colleagues, several have asked me how to organize all this. The truth, until now I have not been able to give you a more detailed explanation. If you have any questions, leave them in the comments, and if you already have ideas or know other details about IP transit, don't cut yourself. Right, a good me will thank you for it. If I find interesting solutions that can be used in IP transit, I will make a new video and share it with you. Praying. Thank you all for your attention. Glory to Ukraine, flag of Ukraine.
Generate by AI.